Hello students and everyone, this is Gaurav Mishra and I welcome you all to GM Physics. I hope you all are fine and doing good. So let's have a look at today's topic. In fact, today's lecture is going to be very short because it's about only one thing, that is angle between vectors. I have recorded a separate video lecture for only this topic, that is angle between vectors, only because it's very important in the sense that this concept will be used in almost every chapter for problem solving. If you exclude heat and thermodynamics and modern physics, some portion of modern physics and heat and thermodynamics, if you exclude these chapters, then I think in every chapter, in one question or the other, you will be required to use the concept of angle between vectors. And if this concept is not clear, I am 100% sure you are going to get a wrong answer. So it's important to understand this topic, that is angle between vectors. So without wasting any time, let's begin. Alright, so angle between vectors, right? You are already familiar with the term angle. You already know what does it represent. Angle is the measure of amount of rotation of one line with respect to the other line. By how much value, by how much amount one line is rotated from the other line. That value or that measurement is what we call angle. I mean, if we have two lines, let's say we have two lines, this is line number 1 and this is line number 2, right? So suppose this line number 2 is brought parallel to line number 1. So by how much amount it is rotated, or by how much amount you will have to rotate to make it parallel to line number 1, that amount, that value is what we call angle. So whether you say by how much value line number 2 is rotated from 1 or 1 is rotated from 2, that is the angle between these lines, right? So in that way, there is one more possibility. This can also be one of the angles, right? So this is one pair, this is another pair. So we have two pairs of angles between two lines, right? Vertically opposite angles, right? So which of these to be expressed as the angle between the lines? So we have certain conventions. What is that convention? We generally choose the smaller angle. For example, here you see one of the angles, this one is smaller than 90 degree, the other one is greater than 90 degree, called acute angle. This is called obtuse angle. We generally express the acute angle as the angle between the two lines, right? Suppose we have two rays, two arrows you can say, like this. What is the angle between them? It is 0 degree because both of them are moving in the same direction, right? So there is no any rotation of one with respect to the other. We call this angle as 0 degree. If the rays are exactly opposite with respect to the other, like say this is 1, this is 2. So by how much value 2 is rotated from 1, that is the angle between these two rays, 1 and 2, and that we call 180 degree, right? So similar concept we are going to use for vectors also. But here it was very convenient to write the angle because these lines don't have any direction, but vectors do have direction. So we have to take care about the direction of the vectors as well while writing the angle between them. So let's have a look at vectors. Alright, so angle between vectors. Let's try to understand it through a very simple example. Suppose we have been given two vectors, A vector and B vector. And the angle between these two vectors is 60 degree. This is what is given to us. This information is given to us that there are two vectors, A vector and B vector, inclined at an angle of 60 degree. Now let's try to represent these two vectors inclined at an angle of 60 degree. Okay. So first of all, I am drawing two lines inclined at an angle of 60 degrees. So I have two lines. One is this line, another is this line, right? I draw an angle of 60 degree. So these are the two lines. Now when you try to draw these two vectors, A vector and B vector, you have many possibilities. How? Look at this. I can draw A vector like this, right? And I can draw B vector like this. But I can also draw like this. First of all, I draw two lines inclined at an angle of 60 degree. What if I draw A vector like this and B vector like this? Right? A vector like this, B vector like this. I'm not wrong, because two vectors inclined at an angle of 60 degree. So first of all, I draw two lines at an angle of 60 degree, and then I am drawing these two vectors. The arrows direction is not specified. We don't know in which direction they are moving. So I do have all these possibilities. I can draw like this as well. I can keep A vector like this and B vector like this. But the lines are inclined at an angle of 60 degree. So see, there are so many possibilities, and mind you, all of them are not same. They are different. You can see. For example, if you see here in case number 1 and case number 2, let me write it. This is case number 1, this is case number 2, this is case number 3. Even one more possibility is there, case number 4. There you can reverse B vector and you can keep A vector same, right? Here what you have done, you have kept B vector same and A vector reversed. So 4 possibilities are there, right? Some of them are same, we'll understand it later, but all of them are not same. They are different. How they are different, I am just showing you. This case number 1 and case number 2 are different. How? Look at this. Here B vector, same, but A vector is in this direction, here A vector is in this direction, and both of them cannot be true. This is a negative vector of this one, and two negative vectors are not equal vectors. They are not same, right? So for vectors, direction is very important. So before writing angle between vectors, it's important to take into account the direction of the two vectors. That's why before writing or expressing the angle between two vectors, we need to follow certain terms and conditions, certain conventions. So what are those conventions? I am writing them in steps. Means before finding the angle between two vectors, what all you have to do, then you will be able to write the angle between vectors correctly. So look, alright, so step number 1 is the tails of both the vectors or the heads must lie at the same point. Means before writing the angle between the vectors or expressing the angle between the vectors, first of all you should meet step number 1. You should meet this condition. What is that? The tails of both the vectors must lie at the same point. Means they must touch each other. Something like this. The vectors tails must be at the same point. They must touch each other. The vectors can be oriented in any direction, doesn't matter, but this condition has to be met. And it's not only with tails, either tail or head, same thing. There is no difference whether the vector tail should touch each other or the heads, like something like this. The vectors heads must touch each other, and touching head or touching tail, same thing. How? You can see here. For example, if I take this vector back, I am shifting it parallelly, and that is possible in vectors because you are not changing their components. So let's call this as A vector and this as B vector, and suppose this angle is theta. So this is the angle between these two vectors, let's say, for example. So if you take this vector back, you are shifting it parallelly, you have not changed anything. Similarly, you take A vector back, so you have taken it, you have shifted it parallelly again, you have taken it back. So this angle and this angle, they are vertically opposite, so this is going to be same. So whether you take the angle when the tails of both the vectors touch each other or the heads of both the vectors touch each other, the angle is going to be same. So this is the first condition, that you have to arrange the vectors in such a way that either tails of both the vectors touch each other or the heads of both the vectors touch each other. So you have to first of all arrange the vectors in that orientation. Then you proceed to measure the angle. Now what is the step number 2? Look here. Step 2. The smaller angle is the angle between the vectors. Now try to understand this one. We have met the first condition, that is either tails of both the vectors are touching, or the heads of both the vectors are touching. Now we can measure the angle. This is one angle, this is another angle. Tails are coinciding, but we have two angles. Similarly, one is this angle, another is this angle. One is this angle, another is this angle. Now which of these two angles should be expressed as the angle between the vectors? So the smaller angle is the angle between the vectors. Means here theta 1 is the angle between the vector, not this one. Here let's say theta 2 and this is theta 2 dash. So theta 2 is the angle between the vector, not theta 2 dash, because theta 2 is smaller than theta 2 dash. Similarly, if I call this as theta 3 and this one as theta 3 dash, then theta 3 is a smaller of these two angles, theta 3 and theta 3 dash. So the smaller angle, that is theta 3, is the angle between the vectors, right? So first of all, you have to put either tails of both the vectors or heads of both the vectors at the same point. Means either tails must touch each other or heads of both the vectors must touch each other. Then you should look for the angle. When you look at the angle, you will have two angles. One of them will be bigger angle, the other one will be smaller. So the smaller angle will be the angle between the vectors. One more important point, rather than choosing a smaller angle, you can also say that the angle is smaller than or equal to 180 degree will be the angle between the vectors. See how? This theta 3 is smaller than 180 degree. This one is more than 180 degree. Theta 2 is smaller than 180 degree. Theta 2 dash is greater than 180 degree. Theta 1 is smaller than 180 degree. Theta 1 dash is more than 180 degree. So we can generalize this entire thing in a simple statement by saying angle between the two vectors is the angle less than or equal to 180 degree between the two arrows when their heads are touching each other or the tails are touching each other. Got it? Alright, so let's look at some examples to make this thing more clear. Alright, so let's have a look at these examples very carefully so that we can understand what we have learned so far. So the question is, find the angle between the given vectors. So what are the given vectors? First question, A vector and B vector. Second question, this is, let's name them A vector, B vector. This is C vector, D vector. This is E vector and F vector. This is G vector and H vector, right? And suppose this angle is 30 degree. So first of all, we are going to calculate the angle between these two vectors, A vector and B vector. So first of all, we have to meet the first condition. What is that? Either tails of both the vectors, that is A vector and B vector, must touch each other, or the heads of both the vectors A vector and B vector must touch each other. It's not that. See here, tail of A vector and head of B vector are touching each other. So this is not the right scene. We'll have to change it. How will you do that? So we can use parallel shifting of vector. I'll just take this B vector like this and put it here so that heads of both these vectors touch each other. So I am taking B vector like this and putting it here, parallel shifting. So see, parallel line, this is my B vector. I have just displaced it parallelly. So I have done nothing wrong, okay? This angle is 30 degree. So if you extend A vector, the line is parallel. So this angle is going to be 30 degree, right? What is the angle that we have to write? Either this angle or this angle. So the smaller angle we have to write, so we'll write this angle. So this total angle is 180 degree. So since this is 30 degree, this is going to be 150 degree. So the answer is 150 degree. This is the angle between A vector and B vector, right? Similarly, look for question number 2. Tails and heads, nothing touching each other. They are separated away from each other, right? So what we are going to do, first of all, I'll shift this D vector parallelly and now touch with the tail of C vector. So let's bring it here and put it here. So this is my D vector, almost parallel. So this is D vector. So if this angle is 30 degree, this one is going to be 30 degree, right? So the angle between these two vectors, C vector and D vector, is 30 degree. Got it? Okay, so now let's look at example 3, question number 3 in fact. This angle is 45 degree. This E vector is making 45 degree with this black line, and this F vector is making angle 15 degree with this black line. Step number 1, either tails or heads must touch each other. These two vectors are separated from each other, so they are neither touching heads nor tail. So what I am going to do is, first of all, I am bringing this vector shifting parallelly and here. So this vector I am placing here. This is F vector, right? So still our condition is not met, because even now tail of one of the vector, that is E vector, and head of the other vector, that is F vector, is touching. So still the condition is not met. But see here, this angle is 15 degree, so this angle is 15 degree. Okay, I have to touch tail and tail of both the vectors. What I'll do, I'll shift it parallelly in the same line, so this vector can be kept here now, F vector, right? It doesn't seem parallel. I'll put it like this. This is my F vector. You have to assume I have drawn along the same line. Okay, so which of the angle we have to choose? The angle which is smaller. So you have to choose this angle, right? Not this angle. Are you getting my point? So what will be this angle? What will be this angle? So this total from this line till this line, this total is 180 degree, and this much is 45 plus 15, 60 degree. So how much is this? 120 degree, right? Total is 180 degree. So this one is 120 degree. So the angle between E vector and F vector is 120 degree. Let's check it once again. I have shifted it parallelly and brought it here. So this is 15 degree. I have extended in the same line. So now I have to calculate this angle. This total is 180 degree. This is 45 plus 15, 60. So this will be 120. Fine. So this is 120 degree between E vector and F vector. All right. So now look at the last question. We have to find the angle between these two vectors, G vector and H vector. Again, these two vectors are separated from each other. So neither heads nor tails are touching each other. So what we have to do is, first of all, we have to shift any one of these vectors so that tails or heads coincide each other. So what I am doing is, I am shifting this G vector parallelly again in the same line. So I can place this G vector here. I can place this G vector here. Are you getting it? This is G vector shifted parallelly, right? We have to find this angle, not this angle. We have to always find the smaller angle, or less than equal to 180 degree. You have to keep in mind either of these two things, a smaller angle or less than equal to 180 degree, whichever feels comfortable. So see, this angle is what I am going to calculate. Okay, so this is 15 degree, and this is, with black line, G vector is aligned at an angle of 60 degree. So G vector is aligned at an angle of 60 degree, and H vector is aligned at an angle of 15 degree. So this one is 60 degree minus 15 degree, that is 45 degree. So between G vector and H vector, the angle is 45 degree. So this is how you have to calculate the angle between the vectors. First of all, you have to coincide either heads or tails, then you have to look for the smaller angle or the angle less than equal to 180 degree. Alright, so this is what we had to learn in this video lecture. We'll again meet in the next video lecture with full of energy. Till then, take care. Bye-bye.